So hello everyone. So in this video, we are going to talk about first type of traversal, pre-traversal, which is known as breadth first search. Now, as the name implies, we discussed that we can have two parameters of tree. One is depth and the other one is breadth. And obviously, the breadth first search means that for any node, I am going to visit its children's first before you know jumping the nodes further down the depth of the tree. Okay. So I'm going to prefer breadth over depth during my traversal. Now, so what this means is that for any parent, A, visit its all of children before jumping to any grandchild, basically, okay? And then how am I going to do that is basically maintaining a couple of arrays. So the first array will store the nodes that I have already explored, and the other array will store the nodes that I'm going to explore in future, okay? So as soon as I, so let's say if I start, I have all of these 3, 4, 7, or 8 nodes that I have. I'm going to put those 8 nodes um, as I'm going to explore each parent. I'm going to put its children in this frontier or fringe queue, and then as soon as I visit each child, I'm going to put that each child from this frontier into this explored set. Okay, so as I'm exploring the graph, I'm moving the nodes from this frontier to explode. Okay, and then adding more nodes into this frontier uh, just because I want to continue visiting different types of unexplored nodes that I have in my graph. Okay, so the first node, so the first set will uh, accumulate all the nodes that I'm going to explore in future, and then another set which I'm going to in which I'm going to put all of the nodes that I've already explored in the past. Okay, and so this frontier or fringe, which represents the nodes that I'm going to explore in future, the exploration will be done in first out, first in, first out basis. And then we are going to talk about this goal test in a bit. Okay, so this is the broader perspective. So in terms of code, what I want to do is that given that this is the graph, what I want to explore A, and then all of A's children, which in this case are B, C, and D in that particular order from left to right. But you can also say that, okay, I'm going to explore from right to left, which in that case will be A, D, C, and then B. Okay, whatever your node of increasing breadth is. So first A, all children of A, which means B, C, D, and then all children of B, which in this case is E, and then all children of C, which in this case is F and G, and then all children of D, which in this case is just H. Okay, so A, B, C, D, E, F, G, H is the order that I want to uh, have during my breadth first search. This is basically I have actually told you the answer before the actual solution, but this is how it will look like. Now, how we are going to do that? So the first queue that we are going to maintain is basically a hash set of uh, the nodes that I've already visited. Now, this is a hash set because you know uh, I don't want to put the same node in this visited set twice. Okay, so this is a unique set of strings that I'm going to that I've already explored from this queue. Okay, and this queue is basically an array DQ. Now, if you remember array DQ, it's an open array queue, which means that you can insert elements from both sides and also delete elements from both sides. But I'm going to restrict myself in in terms of first in and first out, which means that I'm going to insert only from one side, and then I'm going to also queue elements or DQ or let's say pop elements from one side. Okay, so I'm going to restrict myself with although I'm using a DQ, but I'm going to restrict myself in terms of first in and first out DQ. Okay, right. And then so this DQ, in the start, I'm going to insert my node my node A, and then while this queue is not empty, I'm going to do this first in first out query from this queue, which in this case is at the start we are going to have only our node A in the queue, and then once we poll it, and then put this node in our visited set. Okay, so this is what will happen at every node. So once we pop it from the queue, we put it in this visited set. Okay, which is a hash set. And then for this node that we have just edited in our visited set, um, I'm going to explore each child of this node A. Okay, and so but first I'm going to see that whether or not my input graph has any information of A's children. Okay, which in this case, we have already defined A's children. In here we have actually defined 3 children of A. Okay, so this means that this while loop will be executed 3 times, and during each time I'm going to visit some node, some child of A, and then I'm going to see that if that child doesn't exist in our visited set, um, and it also doesn't exist in my queue, only then I'm going to add this child, let's say that child B in my queue. Okay, so obviously my queue doesn't contain anything, so I'm going to add B during first iteration, and then in the next iteration I'm going to add C, of within this while loop, and in the third iteration of this while loop in line 51, I'm going to add D in my queue. Okay, because B, C, D, um, you know they they do not exist in visiting in this visited set, or they also do not exist in this queue. Okay, and so at the end of this while loop, once I have already explored all children of A, you'll see that my queue will have all children of A, and my visited set has this A. Okay, and then I go in line 44, and then I simply pop whatever comes in first from B, C, D, and D, B, C, and D. So this in this case will be B, because B is inserted first, and then C, and then D. So and once I pop B, I put it from this queue and add it into this my add it into my visited list, and then uh, explore all children of B, which in this case is just E. Okay, so B only has one child, and then I am going to insert that child in my queue, which in the start has only C and D, and I'm going to insert the element or the node E in the last. Okay, and then likewise we continue in the next iteration. In the next iteration we are going to explore C and all children of C. Okay, and insert each of those two children into my DQ. Okay, and then obviously while we are exploring a parent, we are also inserting that parent in this list of visited set. Okay, now this so in this case so in this way we are going to continue you know exploring each node as they are inserted in this queue. Okay, um, and then after this node D, when we come over here, you see that this condition, once we are going to explore this E, F, E comes first between F, G, and H, and so once we explore E, and add it into our visited node, you'll see that the graph does not contains any information about each children. Okay, because obviously in this graph that we only have node B, C, and D's children defined. We don't have any information of this node E in this graph. Okay, So in this way, you are going to break out of this, um, of this while loop, because E, F, G, and H, they don't have any information of my, um, my graph doesn't have any information about children of E, F, G, and H. Okay, so this is how, if you just print out each parent as, you are exploring it, you'll see that it will print A, B, C, D, E, F, G, and H. Now, the next thing that I want you to think is, although I've provided you the code for this breadth first search, let's say that you start from any given node, and you want to arrive at any given node. Okay, so node A and node, so your source node A and your goal node G, depends upon you. So you can have any node as your source node within the graph, and any node as your destination node within your graph. How are you going to return me, this path between source to goal node? Okay, if I just provide you, names of these two nodes, which is your source node and destination node, how are you going to provide me a list of nodes that represents, that represents a particular link between any two nodes? Okay, so this boils down to the fact that, that I mentioned that, goal test should be done when inserted, and by that I mean that, once you insert something into your queue, uh, maybe do this test that whether or not this end node is your goal node. Okay, and in that case, just give me the whole path that exists from your current node n to its parent, and then to its parent, and so on and so forth. So I want you to think of how to make change in this code such that when you arrive at a particular child, which is your goal node, how would you give me the path to the source node? Okay. So this is the first thing that you would want to think of. Okay. And the second thing is that, let's say if I read, so right now, my node D only has one child H, but what if I add another child, which in this case is C? Okay, so what if I add a new line in here saying that, my node D uh, doesn't have only one child H, but what if I add another line and define this node C as, as another child of D with some weight? Okay, how would this affect your your traversal? um, so this is the second thing that, once you are doing this dry run in your head, uh, I want you to think about this. So how would you, like, how does this code help you um, to get out of this circular information flow? Okay, so this has something to do with this condition. And then also, what about this second condition? What if I simply remove this second condition, if I do not check whether some node n exists in queue? Okay, uh, so I want you to think of these two conditions and whether or not this second condition is redundant, maybe, or not. Okay, so we will discuss about these three issues in our forthcoming live class. Um, Now, so this was breadth first traversal, which means that I'm going to explore every child of my parent node before jumping down the depth, the next depth of my tree. Okay, but you can also have a depth first traversal where you can say that, okay, I'm going to explore all possible, children, child, and grandchild, or within a particular, depth path before exploring, my child. So in this sense, I'm going to say that I'm going to pick and choose one of my child, and then explore, the children of my child first, and then, so on and so forth. So I'm going to traverse in depth first before going to the breadth. Okay, so in terms of the in terms of implementation, there is no change, except for the fact that um, just change this line from pole to pole last, which means that in breadth first search we discussed that we are going to do exploration in terms of first in first out basis. But if you do it in terms of last in first out LIFO basis, then you'll end up with this depth first traversal. Okay. And by that I mean that is, if you just replace it with pole last, if that is if you query the last element first, then you will see that you're going to explore in the way which is from right to left, which is in this case first node A, and then the last element B, C, D. If you remember that we inserted when we inserted A's children, we inserted this while iteration inserted B, C, and D, and then once we go out we explore B first, but in this case we are going to explore D first. Okay. And so what you will end up with is exploring D first, and then once you add H alongside B, C, in this case we added we added E, but if you add H, then you'll explore the last element, which in this case will be H. Okay, so what you'll end up is basically traversing down the right side first before jumping onto these children of C. So A, D, H, and then C, and then G, and then F, and then B, and then E. Okay. So if you just do exploration in terms of last and first out basis, you'll explore your graph in terms of its depth first, and then breadth in some sense. So this is how breadth first search and depth first search traversal look like in any sort of generic tree.